Welcome to 2-Minute Math with Dr. John, where we cover a math concept in under 2 minutes. That way, if you want to watch it again, it won't take too long. Now, in this video, we're going to look at rational functions. Now, a rational function is represented as a fraction. All right? So, it's a fraction that has an x in both the numerator and denominator. Okay? So, it could even be said that a rational function is like a function divided by another function. Okay? So it'll have x in both the numerator and denominator. Now, this causes interesting things to happen to the graphs of these functions. Now, they usually will have what are known as asymptotes. Now, an asymptote, they are imaginary lines that the graph of the function approaches but never touches. Okay? So, a vertical asymptote may look like this. Now, realize, I draw this way. It's an imaginary line, okay? It represents an x value that's not in the domain of the function, so there's no value of the function along that line. Now, a horizontal asymptote looks like this. It comes straight across, horizontally. It represents a y value that's not in the range of the function. So, the graph of this function may then look like this, where, say, this comes across here and goes up, and then it comes right along that one there, curves, and then follows that horizontal asymptote there. Notice the graph gets very close, but never touches the asymptotes. Okay? Now, sometimes the rational function could have a slant asymptote, usually instead of a horizontal asymptote. So this slant asymptote may go like this. And if it also has, say, a vertical asymptote, well then it's going to look something like this, where it comes up that way and then goes that way. Now, a rational function may also have one or more holes in the graph. Now, a hole is not a line, it's just a point on the graph where the x value is not in the domain of the function. So a hole would be represented like this. You just draw a hole there. Okay? And as the function comes along here, let's say it comes up like this, down, and here it doesn't go across a line, but rather it seems to just keep going on, though it actually jumped over the hole. Okay? It doesn't exist at that hole. There's no y value for the x value of that hole, all right? But the function just seems to kind of hop over it. Now, rational functions may have a few or many asymptotes and holes. Remember, when you hear the term rational, think fraction. I hope this video was helpful. Please like and subscribe, and have a great day.